Okay, hi and assalamualaikum. I representative for this group 10. So basically, our group we gonna talk about the frequency response of circuit by equation D and G. So I gonna introduce our team member. Is basically firstly is Umairah, Farzana, Binti, Norasid. Secondly is me, Norasid, Binti, Hafidzuddin, and thirdly Nurul, Farhana, Binti, Mahmud, and fourthly Mohammed, Abdo, Mohammed. So this is our team member for this group assignment. So next, I will explain of what we're gonna talk today. It's basically list of content. So basically introduction, problem and goals, what we need to achieve, and transfer function, what is a transfer function, what is a dot plot, and the explanation how to solve the equation D and equation D. So lastly is discussion and conclusion for this assignment. So I will explain the introduction of the frequency response of circuit. It is a variation in circuit behavior with change in signal frequency and may also be considered as the variation of the gain and pace of the frequency. So next, I will explain what we're gonna do today. Is basically in this assignment is about understanding how a circuit behave at the different frequency using a transfer function and Bode plots. So in this assignment, we need to firstly analyze the given transfer function, and secondly sketch the magnitude of and phase Bode plot, and thirdly identify pole and zero. And fourthly, from a given Bode plot, find the transfer function and match it. So next, problem. The next content is problem. So what a problem from this assignment is basically is to understand frequency response of the circuit, to make a Bode plot through the transfer function given, and to convert the Bode plot graph given to the transfer function. So next content is goals. Goals is basically what we need to achieve from the problem. So we need to solve the problem. So the goals is to understand the frequency response of circuits, to make a Bode plot through the transfer function given, and thirdly to convert the Bode plot graph given to the transfer functions. So next is transfer function. Is what is transfer function? Basically, transfer function is frequency response of the circuit is the variation in the circuit behavior within in signal frequency, and may also be considered as the variation of the gain and pace with frequency. So as you can see from the diagram, is basically V out over V in to get the transfer function equations. So for the next slide is basically Bode plot. What is Bode plot? Bode plot is our semilog plot of the magnitude in decibel and pace in degree of a transfer function versus frequencies. So as you can see, is combination in transfer function H omega is a requirement to us solve the question by using the requirement. So firstly, a gain K, a second, a pole or a zero at origin, thirdly, a simple pole, and fourthly, a quadratic pole. So from the table that we need to following to solve the equations. Okay, so let's go to solve the equation D. So the equation D, what are giving is H omega equal to 15 J omega over J omega plus 4 multiply J omega plus 10 power of 2. So as you can see from this slide, we share a tips step by step how to solve the equation D. So firstly, step 1, the general state of equation to get a Bode plot. Secondly, the magnitude Bode plot and plot in the semilog graph provided. And thirdly, we need to get the zero and poles. So next, my friend will explain more detailing how to get the final answer to question D.
Hi everyone, my name is Umairah Farzana Binti Norasid. My number matrix is B112410442. Okay, today I'm going to explain how we simplify the transfer function to the standard form step by step. Okay, first we have the numerator and denominator. Numerator we have 50 j omega, and denominator we have j omega plus 4 and j omega plus 10 power of 2. So first we have to make this as a 1, all of this as a 1. So what we should do, times by 4 over 4, 10 over 10 and 10 over 10. Okay, we expand this first. And then sub in 4 over 4, j omega over 4, j omega over 10 plus 10 over 10, and j omega over 10 plus 10 over 10. And then this is the left one, the leftover one. And then we got this answer. Then settle by 50 over 400. And then this is the standard form of transfer function. Then you can plot your dot plot by using this standard form.
Assalamu alaikum wa rahmatullahi wa barakatuh. My name is Mohammed Abdo. My matric number is B1124106646. Now I will present our manual sketching for graph for question D. Okay, as you can see in the equation, we have 4 lines we have to draw it. First line, which is gene 1 over 8. And we have GW, which is our pole. We have 1 over GW over 4 plus 1, which is simple pole. And we have 1 over GW over 10 plus 1 square. For first line, we will draw the gene. Our gene is 1 over 8. So we will not just draw 1 over 8 here in the graph now. We have to put 20 log 1 over 8, and it will be negative 18. So this is our first line coming from negative 18. Second line, I choose to be my pole, which it will be the easiest because it's in the top, and also it's easy to draw it. So how can we draw the GW? So because we don't have any plus or something, so we will start from negative. So we will start from negative 20 to the top, because to up, because GW is in the top, and we will use 20 dB plus 20 dB as our height, and we will use 1 deg as our weight. And we will do this more than once to have the longest line that we can draw it in the graph. Third line, it will be our 1 over GW simple pole, called simple pole. How we can draw that? Because it's in the bottom, so it will decrease, the line will decrease to down by around negative 20. So, and this 4 here, bottom, in the bottom for GW, it will be our reference point. So we'll draw line from the 0 dB until point number 4, going down as we draw. This will be negative 20 and 1 deg, so it will be going down like this, and we'll draw it more as long as we can. Our last line, it will be second order equation. So second order equation, it almost decrease by around negative 14 dB. So for one line, it will be 1 deg. from 10, our reference point, until negative 14 dB. After we draw the whole equation that we have, we'll draw our final line. How can we draw our final line? So we will take the points from 0.1, 1, 10, 100, or maybe 1,000 if you can, but we cannot here draw 1,000 because it's small graph. So do we have another point we have to take it? Yes, we will take 4 because it's reference point. So 0.1 we will take the point, the addition point for each line. So here we have negative 20 and negative 18 and 0. That's all the point we have in 0.1. It will be negative 18. So this is our first point. For 1 we have negative 18 and 0. So this will be our second point. For 4.4, so this is 1, 2, 3, 4 going up. This is negative 18, 0, and almost 12. So if we addition negative 18 plus 12, it will be negative 6. For 10, we have negative 18, we have negative 8, and we have 20. It will be almost 6. Point for line 10, we're going up. We have here negative 18, negative 8 for green line, and 20 for orange line. When we add those points together, we will get negative 6. And for 100,
Okay, my friends is already explained how to get the final answer for the question D. So next is question D. Question G. From the bob plot, obtain the transfer function correspond to it. From the graph we given, we need to graph bob plot. We need to get the transfer function. So my friend will solve. Will explain how to solve the question G.
Hi, Assalamualaikum. My name is Norasid with Hafidzuddin. I'm from BLRS1/1 and laboratory is B112410404 and this is my partner.
Hello, my name is Farhana with Mahmud. You can call me Ain. My number matrix is B1124 10600. I'm from BLR and session 1/1.
Which is 20 log k equal to 20 and we get k equal to 10. So this. So next, a 0 with at plus 20 dB over dk and omega equal to 10 radians. We get a 1 plus j omega over 10, which is this. As you can see, from the graph is increased from 20 to 40 dB. So next, a pole with slope. We get 1 over 1 plus j omega over 100. So at this, so the flat, as you can see the graph. Okay, so next is a pole with slope negative 20 dB over at omega equal to 1000 radian. So we get 1 over 1 plus j omega 1000. So from, as you can see from this graph is 1000. The graph will decrease at negative 20 dB at each hit. So after that we got from the graph g omega equal to 10, 1 plus j omega over 10 and over 1 plus j omega 100, 1 plus j omega over 1000. I think that's all from me for my part.
Okay, hello. Now, I want to present how to convert transfer function to standard form. First of all, this is the standard form. Sorry. This is the transfer function that we got from the previous present by Mohammed. Okay. To get the standard form, we need to eliminate the denominator because in the standard form there's no denominator. So to get the standard form, we need to multiple the numerator and denominator, same with the j omega inside the bracket. So 10 1 plus j omega over 10 multiple with 10 over 10, and here is 1 plus j omega over 100 multiple with 100 over 100, and this one is 1 plus j omega over 1000 multiple with 1000 over 1000. So from there we can get this one. To eliminate the denominator, we put aside the 1 over 10 because we will just want this form. There's no denominator. So we will get 10 multiple with 10 plus j omega multiple with 1 over 10. Over here is 100 plus j omega over 100 and 1000 plus j omega multiple with 1 over 1000. So the excess number over here, the fraction, we will multiply it. So we will get 100,000. So 100,000 is again 4k. We put in front of here. Okay, what 100,000 multiple with 10 plus j omega over 100 plus j omega multiple with 1000 plus j omega. So we need to replace the j omega into j omega to s. So the standard form for this dot plot is 100,000 multiple with 10 plus s over 100 plus s multiple with 1000 plus s. So that's all for today. And to summarize it, we read the slope and breakpoint from the plot to find the poles and zeros. Then write the transfer function in omega, and finally convert it into s to get the standard form. So that's all. Okay, thank you.
So my friends already explained how to solve the question G. So next, I will explain the discussion. In this assignment, we focus on the use of the transfer function and Bode plots to study the frequency response of electrical circuits. The transfer function H omega describes how the output of the circuit responds to input signal at a different frequency. So from the given transfer function, we identify impulse and zero, which determine the shape of the Bode plot. So next, we need to sketch the magnitude and phase Bode plot using semilog graph paper. This plot helps us visualize how the circuit behaves across low, mid, and high frequency, whether it amplifies or attenuates the signal. We also work the other way around. Starting from the Bode plot, we estimate the transfer function by identifying breakpoint and change in slope. This requires understanding how each pole and zero affect the plot behavior. Okay, so last but not least, we gonna explain the conclusion what we get from this assignment is basically plotting the Bode plot from a transfer function help visualize how a system responds to different frequency in terms of gain and phase shift. Secondly, we get the frequency response of a circuit, show how the circuit amplifier or attenuate signal of different frequency and how it shapes their pace. And thirdly, obtain the transfer function from a Bode plot allows you to mathematically model system frequency response based on its magnitude and phase behavior. So we going to summarize the assignment what we have done. For this test, we learn how to read the understand transfer function, sketch and explain what magnitude and phase plot, and thirdly, identify poles and zero, and finally, reverse transfer function from a dot plot. So through this process, we saw how circuit respond to different frequency, which is very useful in real life application like design, filter, or amplifier. I think that's all from us for this assignment. I would like uh, say thank you and enjoy watching. Bye.